Yes, we were discussing about the frames in which we have taken the example of this university also. And in the last lecture, we have discussed about the frame-based system. So now today we will talk about the forward chaining and the backward chaining methods. And before that, what comes under the frame? What is the description of about frames? Each frame should represent either a class or an instance, because we have talked about that the frame-based system is a data structure. So in case and it follows a modular structure, and then here we are talking about should each frame should represent a class or an instance, and each class and the class frame represent a general concept, whereas the instance frame represent the specific occurrence of the class instance. So simply we have talked about here the object-oriented approaches. So we are talking about here the classes. Class frame generally have a default value in the frame-based system component. We have talked about the four components: slots, specs, default values, and the procedure. So here we are talking about the class frame generally have a default values which can be redefined at the lower levels. And here we have used the advantage of object-oriented techniques, the inheritance also. If a class frame has an actual value fact, then the descendant or the child one frames cannot modify that value. Value remains unchanged for the subclass. So these are the properties you should follow in a frame-based system. Values remain unchanged for the subclass and instances. And in case of when we are talking about the inheritances in the frame, suppose we want what is the inheritance in a frame we have talked about. Suppose we want to know the nationality or the phone of the instance frame 13. This information are not given in this frame, so search will start from the frame 13 in the upward direction till we get our answer or have a reach the root frame. So here we are talking about the parent node. Another frame can be easily represented in a prologue by choosing the predicate name as a frame with two arguments. First argument is the name of a frame and the second argument is the list of a slot, so the fact pair. Now what are the features of a frame representation? Frames can support values more naturally than the semantic nets. Example, the value 25. Frames can be easily implemented using object-oriented techniques or in object-oriented programming. Them allow for arbitrary function to be embedded in a representation, but a price paid in terms of efficiency, generality, and the modularity. Inheritance can be easily controlled here in a frame-based system. Now we have talked about the complete three knowledge representations in which we have talked about the semantic networks and the frame-based system, and here we are taking the another example. In the semantic network, we have taken this example, and this we can say the extended form of a semantic network, where we are showing the relationship between the concepts animal, mammal, deer, bird, cat, bird, the fish, water, and the whale, and relationships or the association between the various or the different concepts. So here we have talked about the semantic network. So and the frame network also. Just in an overview, we are saying that a frame network or a semantic network is a knowledge base that represents the semantic relationship between the concepts in a network. It is often used as a form of a knowledge representation only. It is directed on the undirected graph consisting of the various vertices which can represent the concepts and the edges which represent the semantic relationship between the concepts, mapping of the connecting semantic fields. And a semantic network may be initiated as, for example, a graph database or a concept map. Examples of a use of a semantic network we are using here the logics, the directory cyclic graphs, and other semantic cyclic graphs that we have talked about.